Hi, I'm DJ Spry from Juniper Networks, and I work on Apstra and Tenant-based networking software. And today I'd like to go over a live demo of the automated data center in action with you. A quick agenda. What we'd like to do is to show you how you can quickly and reliably enable new business and networking services, and how you can quickly and reliably, recover data center fabrics to a new previously known good state. Also, we're going to cover how you can identify network service level objective issues and reduce your mean time to resolution, your mean time to innocence, as well as have better network insights with real time and historical analytics, all of which with a drastically simplified user experience to increase your business uptime. With that, I'd like to hop directly into the demo. Okay, I'm logged into Apstra, and you can see that there is a data center in Austin, Texas being managed by Apstra. So the first thing I want to do is create a new tenant or security zone or VRF in order to place my new application in, or my new service. So I'm going to call this prod, and I'm going to hit create. It's as simple as that. There's additional options that you can choose from, but you can do it as easy as in 2 clicks. Apstra at this point in time is going to provide some checks and say, hey, in order to establish this new security zone, we need to establish, you need to give some additional information. In this case, it's some loopback IP addresses for the network resources. All right, the next thing we need to do is create a new virtual network that we can place this application in. In this case, this application is an amazing new app that we want to put into production. We want this quickly and reliably into service. We expect a lot of demand for this, and everyone's really excited. And you could specify addresses manually, like I'm doing here, or you could allow Apstra to auto-assign these resources through a resource pool that is available as an internal IPAM capability. I'm going to enable these as VLAN tagged interfaces across every interface in the data center, again, because we believe the demand for this application is going to justify that. So I've just provisioned this new virtual network everywhere in the entire data center in just a few short clicks. And if I wanted to look at the configuration that Apstra automatically renders, I can do that here and scroll all the way down as an example. And I say, hey, there's a new VN3. And if I look back, a virtual network for my amazing new app, I can see the VN3 on Leaf 3 is for my amazing new app. So again, that's a very high level declaration interface that's presented to the user. And Apstra automatically, through its data model, renders all of the configuration necessary for the underlying network devices and operating systems. So looking at the uncommitted tab, here is where you review what you're about ready to, or what you're allowed to push into production. In this case, there's no errors. And I am reviewing that, yes, in fact, I do want to provision prod in my amazing new app, and I can get some additional information before I push this in. But this is exactly what I want to deploy. And I'm going to go ahead and commit this. So deploy new app. What happens at this stage is Apstra also takes a snapshot or a copy of the entire network state and of the graph database and saves it every time on every successful commit. And I can use Intent Time Voyager to look back at all of the past commits, successful commits that's happened inside the network, and jump to any of these revisions. So here, unfortunately, what happened is that the application team found an issue and marketing team wanted to delay the launch of our amazing new app. So what I want to do is go ahead and jump back to this revision. And again, this could be the same people that deployed it, or it could be completely different people have no idea of the context of what exact configuration was made, or what the individual command line elements for every individual device. They don't need to know that. You can jump back and restore state across the entire data center fabric in 1 click. So this, you can go from broken to unbroken, or rollback, application deployments in single clicks. You get the same validation engines that from Apstra with Intent Time Voyager as you do with initial configuration deployments through staged. So here I can see that I want to remove prod or remove my amazing new application. I'm going to go ahead and commit this and say removing amazing app, VN, and security zone. So this is DJ. All right, and just like that, everything is removed. Configuration is being deployed. You can see that there is nothing pending. If I go to my staged review, there is no more amazing new app. And if I were to look at the physical configuration interface of Leaf 3 that we just looked at, you can see that VN3 is now removed. All right, so I've logged into another instance of Apstra managing another data center in Austin, Texas, but very quickly I can determine that there are issues affecting the service in this data center. So I'm going to go ahead and click into it. You have a dashboard right off the bat that shows you the health of the data center across many different facets from both configuration deviations, interfaces, cabling, BGP, and route. So slow responses to service disruptions or end user experience issues can result in a loss of customers, corporate reputation, and certainly revenue. The Apstra intent-based design in closed loop analytics builds a feedback loop between what the architects who built the system and the operators who are responsible for ensuring how that service or is that service working in production. And because Apstra is used from both day 0 all the way to day 3, the documentation is always up to date, and the closed loop or live query capability allows real-time notification for any deviations. In this case, you can see that there's a configuration deviation, issues with interface cabling and BGP. Scrolling on down, there's this node status, and I like to refer to the blast radius to see what devices are most impacted and how they're impacted. I'm going to focus on Leaf 3, and it's a bit like Google Maps. Is the further you drill down, the additional bit of information you receive. So here it's not just validation of configuration, but of networking states and networking elements. And because the policy is declared through the user through Apstra, we understand the network behavior and continually audit the network to see if it's in accordance and behaving as it should be. And in this case, even though that there is a route to 10.0.0/32, it's not the route that is expected to be there from the service that was instantiated. So here we are receiving a route with the next hop is 172.16.0.10 where it should be 0.4. So there is a deviation here. Another bit of information is that we append or Apstra appends data that is useful to the operators. And here it's just not a route, but it's a route from spine 2 as an example. So again, this is presented a lot of contextualized data from BGP, LDP, and interface, but focusing on configuration. As Apstra is now the single source of provisioning, any deviation that happens to the network is immediately raised and flagged to the user. So here you can see that there's been an interface XE000 that has been disabled on this particular Juniper device. So this could be something innocuous or it could be malicious, but the point is that you always have confidence and 100% accountability of what is running in your network at all times. Last thing I want to show is how operations teams can leverage Apstra to identify and isolate issues in the routing protocols themselves that may be impacting network availability or service level objectives. So it's impossible for any person to mentally keep track of all the EVP and route types and the control protocol behavior for every network provisioned in the data center. But Apstra, rather than trusting the network and the protocol behavior, is codified into an IBA probe or an intent-based analytics probe that is constantly validating the health and the accuracy of the EVP and control plane, RIB, and flooding domains on every switch and raises anomalies for any deviation. And here is a deviation that Apstra has identified for the EVPN VXLAN Type 5 validation. Rather than looking at this individual probe, what I'd rather show is that you can create dashboards of probe and analytic data most important to you and your business. As an example, this dashboard is showing east to west traffic, server traffic, traffic exiting the data center in the last 12 hours. The relationship in the graph database, along with the IBA, presents you with this rich contextual data that is always running and reducing the number of tools and interfaces you have to jump. Here's that EVP and Type 5 anomaly raised by Apstra that is impacting the 11.0.0/24 network, while others remain unimpacted. So here, if I go and look, I can see the 11.0.0/24 is impacting my red database. This is analysis you can't get from traditional network monitoring tools or existing products, and Apstra does this dynamically for every virtual network provisioned. I have purposely deactivated the routing and bridging interface for Virtual Network 2 or Red Database 01 on the Juniper device Leaf 3, which is part of an EVP and VXLAN fabric here. in order to force this loss of the route type 5 and to trigger this anomaly. So now that we see how quickly you can locate and isolate issues, let's see how simply you can restore the entire network as a single system back to compliance and restore the network services to the database. All you have to do to put Leak 3 back into compliance is navigate to the Active tab, go to Telemetry, and find the configuration deviation. And here you see this Apply Full Config. Apply Full Config puts on Confirm will take the golden configuration and render it back to the device. So here is the configuration that is inactive. And if I run this command again, you can see already that Apstra has put the configuration, the golden configuration back on, and that everything is okay. Going back to the dashboard, you can see that anomalies are clearing. Red things are going to turn green. From EVPN routes to cabling, BGP and anomalies, but you can already see that the configuration deviation is gone as well as the cabling. So this portion of the demo shows how anyone can quickly and reliably identify service level objective issues and reduce the mean time to resolution, mean time to innocence using closed loop intent-based analytics. And now for the final part of the demo for today. So here I'm logging into a new instance of Apstra, which is managing a data center in Switzerland. And if you navigate to the Active tab via the full topology, there is a layer option that overlays real-time data usage and interface statistics for you directly onto the topology. So this is real-time information. And the more that you click or the further you drill down, very similar to the previous, it's like Google Maps, the more detail you get. So here I've navigated down to this particular device. And if I hover over, I can get real-time statistic information and optic information, how much data. So there's actually one step better where you can click on headroom and you can choose any endpoint in the network and look at the live traffic utilization across all points of the network for which that data would traverse. So here I'm going to choose Rack 2, and you can see that the data traffic is a bit different. Additionally, there is a DVR-like capability, this time series database, which allows you to go back in time and view the data as it traversed across those same endpoints in real time. So here I can see what data happened to be traversing across this link. I can move it around. I'm going to move it to this day. So this is really useful for forensic or an analysis if you want to go back in time and say, for instance, the database team said that we did a database replication, but it didn't seem like the data was traversing the network or we had an issue. So here you have the ability to go back in time, choose the aggregation of how you want, and prove whether or not that the data actually traversed in the network at that moment in time. And again, you can look at this from a topology standpoint across any point in the network and any device. Okay, well, that concludes the demos today. So to recap, what we've done is shown how you can quickly and reliably enable new businesses and networking services, recover and enable data center fabrics to previously known good states, and to identify issues in the network, identify those service level objective issues, and reduce your mean time to innocence, to gain a better network insights with real-time and historical DVR-like capabilities of analytics that dramatically, simplifies the user experience and increases uptime. Apstra is an intent-based networking solution that provides a unified, consistent, and seamless experience from the architects day 0 to the operators on day 2 plus. And it does so in a closed loop and an automated fashion. To really restate is Apstra delivers on business outcomes. So you can see here that there are some pretty shocking numbers, the 99% in improvements on agility and infrastructure agility. But really when you look at what you can do with Apstra in seconds and minutes as compared to weeks and months, you can really quickly understand or easily understand where those 99% numbers come from. If you're interested, you would like to learn this or try it out yourself, we have a few links on the screen here. There's Apstra Academy, YouTube playlist, and even a cloud-based lab environment sandbox at Juniper V Labs, where you can try this out for free.